Correlation. When bivariate data is drawn on a scatter plot, the closer the points are to a straight line, the greater the linear correlation between the two variables. If two variables are perfectly correlated, then the points will lie on a straight line. But this is very rare in statistical investigations. In almost all cases, the points are scattered. We need a way of quantifying how closely the points on a scatter plot are approximated by a straight line. This is called the line of best fit. This job is done by a quantity known as the correlation coefficient, and it's denoted by the letter or. Or is always a value between -1 and 1. The sign of or has to do with whether the line approximating the data, i.e. the line of best fit, is increasing or decreasing. The value of or has to do with how close the points lie to the line of best fit. The closer the points are to the line of best fit, the closer the value of or is to 1 or -1. If the data is very scattered, then the value of or will be close to 0. Positive correlation. If, in general, the values of y increase as x increases, then there is said to be positive correlation, i.e. the value of or, the correlation coefficient, is positive. In this case, the line of best fit will be increasing from left to right. In the scatter plot shown opposite, the line of best fit is increasing as we go from left to right. Thus, or, the correlation coefficient, is greater than 0. So we can see it's going uphill from left to right. Negative correlation. If, in general, the values of y decrease as x increases, then there is said to be negative correlation, i.e. the value of or is negative. In this case, the line of best fit will be decreasing from left to right. Thus, or is less than 0. So we can see the line of best fit is going downhill. No correlation. If the points are scattered at random, then there is no correlation between the two variables, and the value of or is 0 or very, very close to 0. So we can see here they're scattered. There's no line that can be drawn in. So this would mean that there's no relationship between the two sets of data. Some examples of scatter plots, their lines of best fit where applicable, and the corresponding values of the correlation coefficient or are shown below. The line of best fit is the line that goes through the middle of the data. In theory, it is the line where the distances from the points on both sides of the line balance each other. So here we have or equal to 1. We have positive correlation because it's going uphill, and it's equal to 1 because all the points are literally along the line. Again, we have positive correlation here. We're going uphill. And or this time is equal to 0.78. So that's quite a high number. That's quite close to 1. And we can see that most of the points are close to the line of best fit. We have a couple that are a little bit further away from it. Here we have or equal to 0, no correlation. Here we have an example of negative correlation, so it's going downhill, the line of best fit. And this is or equal to -1, so again all the points are on the line. And here we have again some more negative correlation, so it's going downhill. But this correlation we would consider to be moderate or even verging on weak. So we have an or value of -0.41. So it's just barely moderate correlation. Whereas up here we have much stronger correlation, and here we have very, very, very strong correlation. In general, correlation is divided into strong, moderate, and weak, based on the value of or. The following diagram gives a commonly used scale for these, but depending on the circumstances, small variations in these are possible. So we can see at the center we have 0, no correlation. To the right we have positive correlation, and to the left we have negative correlation. So let's start off by having a look at positive correlation. If our OR value is between 0 and 0.3, we have weak positive correlation. Between 0.3 and 0.7, we have moderate positive correlation. And between 0.7 and 1, we have strong positive correlation. If we have an OR value of 1, we have perfect positive correlation. If our OR value is between minus 0.3 and 0, we have weak negative correlation. If it's between minus 0.7 and minus 0.3, we have moderate negative correlation. And if it's between minus 1 and minus 0.7, we have strong negative correlation. And if we have minus 1 for our OR value, it's perfect negative correlation. Some notes. The correlation coefficient OR has no units. Thus, the value of OR will not be altered by changing units from, say, meters to centimeters when measuring height and so on. If all the points on a scatter plot lie in a horizontal line, or they all lie in a vertical line, then we can either say that the correlation coefficient is not defined or is equal to 0. The data should be as representative as possible of the population about which we want to determine a possible correlation. For example, if we're investigating the link between time spent playing sport and annual income, it would not be representative to only consider university graduates in their 20s.